Hello everyone, my name is Michał Zmysłowski and today I will try to answer the question: is noisy quadratic model of training of deep neural networks realistic enough? But firstly, let's answer the question: what is a model of training? Well, to me, this is a theoretical model that captures behaviors of empirical risk function during optimization of neural networks. Empirical risk function is basically the average loss over the training dataset. But what types of behaviors do we want to capture? Well, but in this work we will be mainly concerned about with effects that batch size has on the training of neural networks. Okay, but how can we create such a model? Well, we can base our assumptions on the empirical properties of the empirical risk function. Are there any examples of such properties? Yes, there are. Importance of initial phase of the training, convex quadratic behavior near a minimum, the tendency for white minima to generalize better, the correlation between the batch size and the learning rate and the curvature of the loss function, and the importance of covariance of gradient. And the noisy quadratic model from the title is based on the two assumptions: quadratic convex behavior near a minimum and importance of covariance of gradients. Concretely, the authors assume that the function being optimized is a diagonal quadratic form and that the gradient has an additive noise with mean 0 and covariance c. But to simulate how the batch size works, the authors divide the gradient by b, and this makes the covariance equal to c over b. Does the noisy gradient and this dividing by c models the effect that the batch size has on the optimization of neural networks? Well, in our opinion, no. This is our main result. In the first row, you can see the training of simple CNN on CFAR10 with SGD, and in the second row, you can see the training of NQM, and each column represents different learning rate. And as you can see, changing the batch size increases the convergence speed for simple CNN, while increasing batch size for NQM doesn't change the convergence speed. Here is our another result. It challenges the quadratic approximation that NQM makes. We show that the training of simple CNN with a relatively big batch size diverges. In the first graph, you can see the training of simple CNN with two batch sizes, 128 and 2048, with a learning rate 0.1. The red markers indicate the time when each model reached the lowest loss value. We can see that the model with the batch size 2048 diverged a few hundred iterations after reaching its lowest loss value. The next two graphs show you what happens in the last iterations before the divergence of the model with the bigger batch size. Basically, SGD finds, relatively to the previous values on the optimization trajectory, much steeper region in the vicinity of the weights with the lowest loss value. We can see this by noting that the gradient norm, the picture in the middle, starts changing abruptly before the norm of the weight starts to change. This is picture in the right. NQM is unable to model this behavior because of the quadratic approximation. Thank you for your time, and I'm waiting for your questions.